Hello and welcome to Types of Energy. We are in the Unit Global Energy Budget. Okay, so we're going to talk about the different types of energy: nuclear energy, gravitational potential energy, kinetic energy. Okay, so what is energy? Energy is the measure of the ability of an object or a system to perform work. We are going to go into what work means additionally in another lecture. So there are many types of energy. There's kinetic energy, which is the energy of an object due to its speed. Gravitational potential energy, which is the energy of an object due to position in a gravitational field. Elastic energy, which is energy stored when an object is stretched or compressed. Chemical energy, which is energy stored within chemical bonds. And nuclear energy, which is energy stored in nuclei. So when work is done, energy is transferred. And that energy might be gravitational potential energy, so like when an object changes height within a gravitational field. Kinetic energy, when an object changes speed. Light energy, when a light bulb is switched on. Heat and sound, when a car brakes sharply. Okay, so the law of conservation of energy states that energy cannot be created or destroyed. It can only be changed into another form. So in other words, the total energy of a system is constant. A bungee jumper's gravitational potential energy is changed into kinetic energy as they jump, and then stored as elastic potential energy as the bungee rope stretches. So this concept is familiar to us. We understand that in the conservation of mass, it's the same type of idea that mass is not created or destroyed. So we're used to this way of thinking. And I encourage you at any point in these lectures to pause something. So if you want to look at a picture and read the cue, or if you want to hear something that I said again, or have extra practice with a problem, I encourage you to pause the lecture, rewind to where you need. You can watch these things over and over again. Okay, so energy is not something that is seen or observed directly, and cannot be thought of as, can be thought of as the ability to do work. So an object may have energy due to its motion or its position, and that energy can be transferred or stored. Energy exists as different types and can be transferred or changed from one form to another depending on what the system is. So the amount of energy an object has is measured in joules, as power is in watts. Okay, and there are 9 different types of energy that you need to be aware of for Cambridge: light energy, sound energy, kinetic, nuclear, electrical, chemical, elastic, gravitational, and thermal. Okay, and you know, like we talked about at the beginning of this lecture, there are several more, but these are the 9 that you are held responsible for. So let's talk about light energy. Light is a form of electromagnetic radiation. This is energy carried by vibrating electric and magnetic forces in transverse waves. Now, later in the semester, we really go into detail about what the different waves are and what transverse waves are. For now, it's important for you to understand that light travels in straight lines, and because of that has the properties of waves. Okay, the sun is a light source, as is a filament lamp or a firefly. So how do we see objects? The only way that we see in our daily lives, any object that we see, anytime we can see anything but pitch black, it's because we're seeing light being reflected off of objects. And I know that that can be kind of a hard concept for people to understand at first. But the color of light so we can see many colors of light. All light looks white to us, and that's because it contains many colors of light. But the color that has the most energy, do you know if it's red or violet? Okay, it would be violet. Okay, so sound energy. Sound energy needs a medium through which to travel. Sound energy is transmitted by vibrations of particles in the medium through which it is traveling. So sound travels in longitudinal waves. The louder the sound, the more energy it transmits. And the quieter the sound, the less energy it transmits. That's really the important thing to remember about sound, is that it needs an energy, or it needs a medium to travel through, which is why so many people critique movies like Star Wars and whatnot, because when you're in space and if you're in a vacuum, you wouldn't be able to hear things exploding, right? Because sound has to have a medium to travel. All objects have thermal energy. It is the energy of a substance due to its kinetic energy. And the more thermal energy a material has, the hotter it is. So in which state of matter, solid, liquid, or gas, do water molecules have the most thermal energy, and why? You can take a minute to think about that. You can always pause to think about it and then push play again to continue. Okay, ice, frozen water, has the least thermal energy, and we know due to kinetic theory that molecules that are frozen have little kinetic energy. And the colder they are, the less they are moving. Liquid water has more thermal energy than ice. Its molecules have higher energy, and they can pass by each other and are still held together. Whereas water vapor has the most thermal energy. Its molecules have lots of kinetic energy and are moving so fast they are no longer held together. Hey, electrical energy is carried by wires and is the energy that electrons have as they flow around a circuit. And it's useful because it is a convenient way of transporting energy to a particular location or device. Electrical energy can be used to do work in a wide range of different devices, as you all are very familiar with. Elastic energy is so if a material like this sponge in this picture is squashed or compressed, when the material is released, it has the potential to return to its original shape. So we learned about this when we learned about Hooke's law. Okay? The energy stored in compressed material is called elastic energy. And it's the same for for materials that are stretched. They have the potential to return to their original shape. So they also store elastic energy. We know when they reach that portion where they can no longer return to their original shape is called the limit of proportionality. Chemical energy is a type of energy that is released by chemical reactions. So fuels, food, and batteries all contain chemical energy. When a fuel burns, energy is released by a chemical reaction with oxygen. Respiration is the process used by the body to release this chemical energy that is stored in digested food. The particles in the nucleus of an atom are held together by strong forces. Some atoms, like uranium, have a very large unstable nucleus, which can be split into two smaller nuclei. And the splitting itself is called fission. And the process of splitting the nucleus releases a huge amount of nuclear energy. And the release of nuclear energy is exploited in nuclear power stations and some atomic bombs. A uranium nucleus is split by bombarding it with neutrons. The fission forms two new elements and two neutrons. The new neutrons can cause other nuclei to split, which releases even more neutrons, which is called a chain reaction. Atomic nuclei can also join together, which also releases a huge amount of energy, and this is called fusion. So nuclear fusion is a process that releases energy inside stars like the sun. Okay, any object in a gravitational field has gravitational potential energy due to its position in the field. The moon has gravitational potential energy due to the gravitational field of Earth, and the Earth has gravitational potential energy due to the gravitational field of the sun. So its amount the amount of energy that it has is due to its position in the field. The gravitational potential energy depends on the distance between two objects. Okay, the gravitational potential energy of an object on Earth depends on its weight and its height above the Earth's surface. So when a bungee jumper starts to fall, they start to lose gravitational potential energy. As the elastic cord pulls them back up, they gain it again. Okay, kinetic energy is the energy an object has because it is moving. The greater the mass of a moving object, the greater its kinetic energy. If the mass is doubled, the kinetic energy is doubled. The greater the velocity of a moving object, the greater its kinetic energy. So if the velocity is doubled, the kinetic energy is quadrupled. So if the velocity of a car is slightly above the speed limit, its kinetic energy is much greater than it would be at the speed limit. This means it is more difficult to stop the car, and there's more chance of an accident. Keep that in mind, kids. So the kinetic energy of an object depends on its mass and its velocity. Okay, the equation for calculating kinetic energy is Ke equals half times mass times velocity squared. And the units of kinetic energy, mass and velocity, so we know kinetic energy is measured in joules, mass is measured in kilograms, and velocity is measured in meters per second, or meters per second squared. Okay, so here is a kinetic energy problem. So what I would like you to do is I would like you to get out a piece of paper and a pencil. I need you to pause the video and start working the problem. You can move back, you can rewind the video to get the equation again if you need to, but I need you to do these practice problems and turn them into Schoology. So a car has a mass of 1,500 kilograms and is traveling at a velocity of 10 meters per second squared. What is the kinetic energy of the car? Pause the video now, work out the problem, and then hit play again for the answer. Okay, so the car, if you're doing half times mass times velocity, it's half times 1,500 kilograms times 10 meters per second squared. And the answer would be 75,000 joules. Okay. As we well know, it is often necessary to rearrange an equation to solve for a different part of it. So to rearrange this to solve for mass or velocity, okay, so we know how to do this. Okay, so mass equals 2ke over v squared, or if you're solving for velocity, it equals the square root of 2ke over m. Okay, so get ready for some more problems. Write down these equations. You guys are responsible for memorizing these equations and being able to work these problems in an exam. Okay, here is a problem. Please pause the video and work out the problem. Again, guys, you can just keep letting it play and just watch the calculations instead of actually practicing it, but you're not doing yourself any favors by doing that. Please pause the video, work these problems out. Okay, final answer, 7.75 meters per second squared, or meters second to the -1. That is it for types of energy. Please continue to watch the next video, which is energy efficiency. Thank you.